Hey guys, welcome back to another RSK Maths video, and in this video we're going to be solving the Senior Maths Challenge 2018 question 25. This simple question here, at least simple, it appears on the surface. So what we're going to do is going to get a SketchUp, and then we're going to use some tricks associated with circles to solve this. So there we go. That is my semicircle. Just pretend it's a semicircle, don't need to worry. And what we're going to do first is we're going to say this big circle has a radius of 1. That way we can just work out the absolute area of this semicircle within. Sorry, I meant quarter circle, but we can work out this absolute area of this semicircle within. And then if we just put that over 1, that'll give us the fraction. So it's just a simple way of getting the fraction. Is just going to be now the absolute area within this semicircle. Now here's the important thing. So we'll go from the center of this semicircle and we'll go down to where it touches it. And we know since this is tangent, the radius to a tangent is 90 degrees. So that's 90 degrees there, and similarly that is also 90 degrees there, even though this is meant to be a horizontal line, but my sketch wasn't that good. And we know since this is the corner of our quarter circle, this is also going to be 90 degrees, which ultimately means there's a square formed. Now I can draw it on this to make it a bit more accurate, but essentially we have this as our square. Okay, now if we call the radius of this semicircle within R, we'll say R here, and we know that this diagonal length is going to be, well, this is now a isosceles triangle with angles 45, 45, 90. So we can just use Pythagoras or trigonometry to get R root 2 over here. So we'll just put R root 2 over there. Now we know this length here is going to be R as well, because that's just radius to one of the edges. So R there. And finally, the last line we need to spot is from the center of the quarter circle to this corner of the semicircle. And since this is also radius, that's going to be 1. So we're able to form a triangle like so in red. Okay, now we have a triangle. What we want to do now is just determine the angles. So one way is pretty simple. You can see we could make a similar triangle over here, same side. This would be 1 and this would be R. So therefore these triangles are congruent, which means these angles would be the same thing. And so we have theta plus theta, and since they lie in a straight line, that's going to be equal to 180. Therefore 2 theta equals 180 and theta equals 90. So we can determine that this angle is 90. Another way we could do it is by observing that this line is actually bisecting the square, so this angle is 45. And then this angle here, well, by symmetry, since there's a line of symmetry like so, we can see this angle is going to be the same as this angle. Both these angles must add to 90, so this must be 45 and 45. Same sort of idea of using symmetry. But yeah, we end up deducing that this is a right angle triangle. So we can form a triangle as such, just rotating it, put the right angle in the bottom right, and we would put the hypotenuse as 1, R and R root 2. Like so. Now we can use Pythagoras to solve for R. So we have R squared times 2 plus R squared is equal to 1. 3R squared equals 1. So R squared equals 1/3. And we'll just leave it like this because we only care about finding the area. So, okay. So now, sorry, the thing I said at the start, we still need to compare the area with the original quarter circle. Made a little mistake there, but it's all right. So let's work out the area of the quarter circle is going to be 1/4 pi R squared, and R is just 1, so it's just going to be 1 squared, so it's 1/4 pi. The area of the semicircle is going to be, well, we have R now, we have R squared, so it's going to be 1/2 pi R squared. No, R squared is 1/3, so we have 1/2 times 1/3 pi, which is 1/6 pi. And therefore we can work out the percentage shaded is just going to be the area of the semicircle over the area of the quarter circle, like so. That is just going to be equal to 1/6 pi over 1/4 pi. Divide pi out and multiply top and bottom by 12, we get 2/3. So that gives us our answer as C. Thanks for watching, and I'll see you guys in the next video. Bye.